We're going to look at examples 1 and 2 in your section 3.2 notes. So in these examples, we want to use our new sum identity for cosines and our difference identity for cosines. So you can see that the start is the same. You have a cosine of the first angle times the cosine of the second angle. And then there's a sign change. So if we're doing the sum identity, the middle becomes a minus. If we're doing the difference identity, the middle sign is a plus, and then we end with the sine of the first angle and then the sine of the second angle. All right, so in example 1, here in 1a, we cannot look at the cosine of 105 degrees. If we try to do this by drawing the picture, our reference angle would be 75 degrees, which doesn't fit in with either of our special triangles, which I've already drawn as a review here. So I'm going to see if I can think of 105 degrees as either an addition or a subtraction of a combination of these angles. So doing that, I figured out that 105 degrees I can think of as 60 plus 45. Okay, so there's an addition. So my first angle, or my alpha, is going to be 60 degrees, and then my second angle, or my beta, is going to be 45 degrees. So I'm going to get this side. So I'm going to have the cosine of 60 degrees times the cosine of 45 degrees. Make that sign change. So we'll have minus the sine of 60 degrees times the sine of 45 degrees. Okay. Now we need to plug in all of our special values from our triangle. So the cosine of 60 degrees is going to be 1/2. Okay, the cosine of 45 degrees is going to be, going over here, we're going to get 1 over root 2, or if we rationalize it, we get root 2 over 2. Okay, next up, the sine of 60 degrees is going to be radical 3 over 2. And then the sine of 45 degrees is the same as the cosine. So we're going to get radical 2 over 2. Okay, so nice thing about rationalizing is we can see that we're going to have a common denominator of 4. So I'm going to go ahead and do that. The numerator is going to be the square root of 2 minus, and then multiplying these two, the square root of 6. And that's the best that we can do. So that gives us our example for part A. All right, now in part B, we have to recognize which cosine identity we have. So it starts with cosines, ends with sines, but we have a plus sign. So we have the cosine difference identity. So we're going to be actually putting this one together. So we're going to have the cosine, and so difference, we're going to take the first angle, 5 pi over 18, and then subtract the second angle, pi over 9. Now, in order to do this, I need to have a common denominator. So I'm going to have the cosine, 5 pi over 18, and then changing this, we're going to get 2 pi over 18. Okay, so now I can go ahead and subtract. When I subtract, I get 3 pi over 18, but that reduces for us to pi over 6. Okay, so remember, pi over 6 is the same thing as 30 degrees. So we can go back to this triangle over here, and the cosine is adjacent over hypotenuse. So we get an answer of the square root of 3 over 2. Okay. All right, so that does it for 1B. Let's look at example 2. Okay, so in example 2 here, we want to verify this identity. So how this works is we want to start with one side and try to get to the other side. So we're going to start with the cosine difference identity here. Okay, so how this works is we do the cosine of the first angle, which is pi, times the cosine of the second angle, which is x. And then make sure you switch signs. We'll have an addition. We'll have the sine of the first angle, which is pi, times the sine of the second angle, which is x. Okay, so now we're ready for some evaluation. So we really need to know about what's happening for pi. So remember that is a quadrantal angle. We can use our ordered pair from our unit circle, which is -1, 0. The cosine is the first coordinate and the sine is the second coordinate. So now we can evaluate. So we know that this answer right here is going to end up being -1 times the cosine of x. And the sine of pi, we're going to get 0 times the sine of x. Okay, so this part is essentially gone because we're multiplying by 0. And here, when we multiply, we end up with negative cosine of x, which was our goal. And that does it for example 2.